Undoubtedly the most boring part to finish off, but it does have to be chamfered and cleaned up, otherwise the edges are too sharp. And then you've got to be careful with it that you don't ding it afterwards. So that's now fairly shiny, pretty smooth, particularly on the underside of it, which is really the only thing that matters. This is mounted on a rather large diameter mandrel, it's just a little slug of cast iron. The brass square has an 8mm hole in it. That dolly is about 9mm to clamp it on. So it's clamped on. I'm going to machine this round to about 30mm, then face it off to get it smooth and flat, and then flip it over and then face off the back side to get it to the right thickness. Be about 1.3mm. What I'll end up with is a thrust bearing or a thrust washer that's the right thickness, the right diameter, but the hole in the middle will be too small. But then I can just expand that out with a sort of a coned expanding reamer type thing. That won't be a problem. Doesn't have to be central, it's not going to go that fast once it's in the machine. Just needs to be nice and clean so it don't squeak and takes the oil. This is going to be very slightly too thick. And it's still got a rough surface on that side, so I'll clean up this remnant in the middle here, just on the emery cloth. Smooth and flat. Measure how thick this is. 1.34. I really only want to take off about 0.05 off of this. Back this out now that it's zeroed on. Take off about 0.05. Clean it up. So, flat on one side, it's already flat on the other side. I've knurled it up a bit around there. I'll clean that up with some emery cloth and whatnot. So I need to open up the hole in the thrust bearing to the size of that shaft. Here we go. It's not a round hole. It's actually hexagonal, but doesn't really matter. Lots of burrs on it, but them off. There we go, one thrust bearing. There's the other one. So there'll be one of these at each end of the shaft to control the end float. So what we have now is the pulley on the shaft, the collet nut tightened up, nice and clean, nice and round. If I was to put this shaft into there now, this pulley would foul on that slider. But that thrust washer is going to go on there. And there's now a clearance there. Very small one, but the pulley doesn't foul on the slider. So the last thing to do was to machine a flat on this sticking out end of the shaft. By design, that shaft shouldn't be that long, it should be flush, but there's nothing to hold its end float. And then machined up a little cap with a grub screw in it to go on the end of that, where that flat is. So the idea is that grub screw there will provide end float control against that thrust bearing and the other thrust bearing as well. So these two little brackets for the handle and the weight slide bar are pretty flat on this this large surface, and they're pretty square on this corner. Now the suggestion is that these are going to be threaded holes, so I would thread them to M10 and then screw the bar into that. Well, there's kind of two things wrong with that. It's an extremely thin piece of cast aluminium, it's very weak, and you're not really supposed to locate something on a thread, because once you tighten it up it will always cock over. That's happened with the hydraulic cylinder slide bar. So I'm going to drill through holes through this, make the thread on the bars a little bit longer, and then put some nuts on the back, some acorn nuts. I'm just hoping I've got enough bar to do that. I might have to pop out and get some more. So the two sides of this thing are now parallel with each other, as parallel as they're going to get. This whole thing needs to be 25mm thick, so I'll take it down to the thickness or the width first, because the flutes on this are not long enough to face off this bottom edge here. So I'll get it down to 25 and then face off this edge. That will put this at a proper right angle to that, and that's pretty much most of the milling done on this, apart from possibly rounding off that end. .99 if that focuses. Probably won't. So there we are, flat on the bottom, parallel on the sides, 25mm thick. There just remains a hole to drill in here and a radius to put on there. I might actually get the rotary table out for that. Alright, so the rotary table's out. A lot of setting up, but I've had a couple of accidents trying to do it freehand, so let's see how this gets on. Yeah, it's tidy enough. Right, start drilling some hole in the end. I do have a 1/2 inch drill to go over the 1/2 inch bar, so that's what I'm going to do. But only drill the hole halfway along, turn it over and do the other side. There's pretty little chance of drilling a hole all the way through this and coming out the centre of the other end. That just isn't going to happen. So this is going to start off with a 6mm spotting drill. I'll go in about 15mm with that to establish a kind of straight, kind of round hole, which is what those drills are for. And this is a factory ground 6mm drill. It's taking out sort of a full cut. There you go, curly swarf. Right, a 1/2 inch drill. See what this can do. Bottom of the hole. One last little job. Now, although when I drill the hole from the other end, yes, it is going to meet up with this hole. Is it going to be straight enough all the way through? I might have to run that drill as far through from both sides as I can get it. I need to get this 1/2 inch drill all the way through and poking out the other side, which gives me some confidence that the other piece of 1/2 inch bar is going to poke out the other side as well. I had actually drilled it from the other end a lot deeper than halfway, and the fact that I had drilled it a very long way in is what sent it off centre, so don't drill deeper than you have to. So there we have it. That needs to have a handle put on the end there. That's well, it could stay like that actually. There's no need for a handle. It's just going to stick out and get in the way. Right, so that's the bar cleaned up, the sliding bar, the weight rod, and the weight. It took quite a bit of getting on there. That hole wasn't straight through the middle, so cleaning out with memory cloth and whatnot. Put it down there so it's easy to deal with. Blind holes on these brackets again. Little acorn nuts on the other side so everything's nice and smooth. Similar nuts to that. And there we go. Getting closer. I'll try and do the handle next. This isn't the best knurling tool in the world, but it's the best one that I could get cheap. So this bit of bar is going to be the handle for the lifting up and lowering down of the whole thing. It's a bit unnecessary actually, but there it is. It doesn't really need to be knurled, but it would add to it. So I've cut a couple of grooves here, start and finish of the knurling. Got to give the knurling somewhere to run into, because it's always going to have a soft edge. And then if it does achieve a knurl on this, I'll then slightly chamfer these grooves out with the chamfering tool. This knurling tool doesn't travel very well. You can't really get into it and then pull it along the part like that, so I'm just going to have to keep pecking into it and moving along, trying to achieve a bit of an even finish. Wish it won't be, but let's see how it turns out. Okay, that's tracking, but it's nowhere near deep enough. Yeah, and this has actually walked itself all the way off the end of the bar, which makes me think it might be easier to start at this end. It would help if I ran it backwards. Yeah, it's pretty much got it. It's not too bad actually. Right, well, as it started off, it went on to the part of the bar that I didn't want it to go on, and I've gone way over the other end anyway. So the problem with this knurling tool, it's pretty wobbly, and it will make its own mind up about how far it wants to travel along. But whilst it's not a full knurl in some places, it still kind of flats on top of the diamonds. It's there, you know, it is definitely knurled. So I'm going to turn this section off here, clean that up, chamfer that end, chamfer the grooves, then drill the hole and tap it, part it off. So I've got to get ready to part this thing off, and if you've not seen one of these before, if you make a little jack to stand under the parting tool like that, that gives the parting tool a lot more rigidity. It takes away all of this sloppiness in the dovetail of the compound slide. Really does make a difference, the quality of the material when you're parting off something like that. A lot of the material I've got is just manky old scrap. That knurl hasn't turned out too bad. You clearly see that it's got different lines and graduations in it, but yeah, has a handle. Time it goes rusty, what's it going to look like? So that goes on there. And come the day, I will put some grips and brass shims on that, give that a good wrench up. So that's the handle that one uses to raise and lower the device. I did say earlier on that handle is not really necessary, you can just lift it up and down here, but the thing is that the blade is the frame is going to be running backwards and forwards, so it's not such a good idea to be grabbing hold of that. If you can be bothered, make the handle.